Today we're diving into one of the biggest shifts happening in AI right now. The move from rule-based automation to agentic, goal-driven systems. They both automate tasks, they both use AI, they both promise efficiency. But underneath, they operate in completely different ways. One follows strict, predefined instructions, the other is given a goal and figures out how to achieve it. And here's why this matters. Choosing the wrong approach can either limit your system's potential or introduce unnecessary complexity and risk. Traditional AI workflows are predictable. They act like digital assembly lines, structured, reliable, and ideal for repetitive tasks. Agentic systems, on the other hand, are adaptive. They can reason, prioritize steps, respond to new information, and iterate until a goal is met. So the real question isn't which one is more advanced, it's which one fits your business problem. In this video, we'll break down how both systems work, where each one performs best, and how you can strategically combine them for maximum impact. By the end, you'll have a clear framework for deciding when to prioritize efficiency and when to prioritize autonomy. Let's get into it.
Let's start with AI workflows. At their core, AI workflows are deterministic systems. What that means is simple. They follow predefined tools. You design the logic, you define the steps, you control the conditions. And because of that, the same input will consistently produce the same output. If a customer sends an email with the word refund, the system routes it to refund departments. If a form is filled empty, the system throws an error. If a payment fails, it triggers a retry sequence. There's no improvisation, no deviation, no independent reasoning. It's structured logic executing exactly as designed. Now let's talk about how these workflows operate. Most AI workflows follow a linear execution model. Think of it like a digital assembly line. Step 1, receive input. Step 2, validate input. Step 3, apply logic. Step 4, produce output. Each step happens in a fixed order. There's a clear beginning, middle, and an end. This structure makes workflows incredibly reliable. They are ideal for structured, repetitive processes where the environment doesn't change much. Things like data processing, document classification, customer ticket routing, schedule operating, these are the perfect use cases because consistency is the goal, not creativity. But here's where workflows start to show their limit. They struggle with unexpected inputs. If something happens outside the predefined logic, the system doesn't adapt. It breaks, stores, or escalates to human. For example, if a chatbot is programmed with a fixed conversation tree and the user asks something slightly outside the script, it won't figure it out. It either gives a fallback response or fails entirely. That's because workflows cannot move beyond their program's instructions. They don't evaluate context dynamically. They don't generate new strategies. They execute what they have been told. Nothing more, nothing less. And for many business scenarios, that's actually a strength. Predictability reduces risk. Let's come with some real-world examples. Email sorting systems that categorizes based on keywords, that's a real workflow. Scripted chatbots that guide users through fixed decision trees, also workflows. Form validate systems that check whether fields are completed correctly before submission, a workflow. Even automated invoice processing systems that extract data and send it to accounting software follow structured, rule-based paths. These systems are not trying to think, they are trying to execute reliably. And when your goal is efficiency and control, AI workflows are extremely powerful. The key thing to understand is this: AI workflows are not autonomous problem solvers. They are structured automation pipelines. They do exactly what they are designed to do, and they do it very well. So if AI workflows are structured, rule-based assembly line, what happens when we remove the fixed path and instead give the system a goal? That's agentic AI comes in. Agentic AI systems are fundamentally different because they are dynamic. Instead of following a strict sequence of predefined rules, they can adjust their behavior based on new information, feedback, and changing conditions. In other words, they adapt. If the environment shifts, the agent doesn't freeze. It reassesses. If a strategy fails, it doesn't stop at an error message. It tries a different approach. This is possible because agentic systems don't want to execute logic. They evaluate outcomes, they process context, they update their next action accordingly. That makes them far more flexible in unpredictable environments. Now here's the core idea that separates agentic AI from workflows. You don't give an agent a strict path, you give it a goal. For example, research the competitors in the market and summarize the findings. That agent then decides what sources should I check, how should I structure the information, what's relevant and what is noise. It breaks the objective into smaller tasks, it prioritizes the steps, it sequences actions. And importantly, it can iterate. If the summary isn't strong enough, it may gather more information. If the data is inconsistent, it may re-evaluate sources. This planning behavior introduces something workflows doesn't have: reasoning loops. The agents can think in cycles, plan, act, and evaluate, refine until the goal is achieved. Another major difference is the level of independence. Once deployed, agentic systems can operate with minimal human intervention. You don't need to guide every step. You don't need to predefine every edge case. The system continuously evaluates its own progress towards the objective. In more advanced implementations, agents can learn from past outcomes. If a certain approach consistently fails, the system adjusts future strategies. This doesn't mean they are perfect, but it does mean they are not limited into a rigid script, and the ability to operate independently is what makes them powerful in complex, evolving environments. Let's look at real-world scenarios where this matters. Imagine an automated trading system. A rules-based workflow might execute trade based on predefined indicators. If condition A happens, execute trade B. But an agentic trading system can monitor broader market signals, detect unusual patterns, reassess strategy mid-execution, and adapt to new data in real time. Another example is autonomous exploration systems. When operating in unpredictable terrain, like country explorations, you can't pre-program every possible obstacle. The system must evaluate the environment, adjust routes, and solve problems as they appear. The same principle applies in business context as well. Advanced research assistants synthesize a large volume of information, AI systems managing dynamic supply chains, personalized customer experience engines adapting to user behavior in real time. These aren't fixed pipelines, they are systems navigating uncertainty. This brings us to the most important distinction: agency. Agency means the system can decide what action to take next, not because you hard-coded every branch, but because it evaluates options based on context and objectives. It chooses, it sequences, it prioritizes. That doesn't make it conscious, but it does make it strategically autonomous within defined boundaries. And that shift from execution to agency is the core of this new era. Now, this doesn't automatically make agentic AI better. It makes it different. With greater autonomy comes greater complexity. You gain adaptability, but you also introduces unpredictability. You gain flexibility, but you also reduce the absolute control. That trade-offs is what makes understanding these systems so important. Because the real decision isn't about how, it's about alignment. Does your program require strict predictability, or does it require dynamic reasoning? That's the question agentic AI forces us to ask. Now that we have defined both systems, let's directly compare. The first major difference is predictability. AI workflows are designed for a predictable outcome. If you run the same input through the system 10 times, you will get the same result 10 times. That consistency is intentional. It makes workflows reliable, auditable, and safe for structured business processes. Agentic systems, however, operate differently. They often rely on large language models, which introduces non-determination. That means the same prompt or goal can produce slightly different outputs across prompts, not because the system is broken, but because it's reasoning probabilistically rather than following fixed rule set. The output can evolve based on context, iteration, or internal evaluation. So instead of strict repetition, you get adaptive variation. The second difference is structural. Workflows move through fixed code paths. There is a predefined sequence: input, process, output. Once the output is complete, the task ends. Agentic systems, on the other hand, operate in iterative loops. They evaluate a goal, they plan a step, they take action, they reflect on the result. And if the objective isn't fully achieved, they loop back and adjust. This loop, evaluate, plan, act, reflect, is what enables complex problem solving. It allows the system to refine its approach instead of simply completing a checklist. The third difference is conceptual. Execution versus agency. Workflows execute instructions. They don't decide what to do next. They follow what was already defined. Agency systems exhibit agency. That means they can decide which action to take next within a defined boundary. They prioritize tasks, they choose tools, they sequence actions towards a goal. Again, this doesn't imply consciousness. It simply means the system can plan rather than just comply. Finally, there's the difference in how these systems handle data. Workflows depend on structured inputs, form fields, drop-downs, type data, things that fit really into predefined category. If the data doesn't match the expected formats, the workflow struggles. Agency systems are far more capable with dealing with unstructured data. They can interpret natural language, ambiguous instructions, contextual nuance, and incomplete information. That makes them better suited for tasks like summarizing documents, analyzing conversations, or extracting meaning from messy inputs. In short, workflows require clarity upfront. Agents can derive clarity from ambiguity. So when you compare them technically, the difference becomes clear. Workflows are optimized for control and consistency. Agentic systems are optimized for adaptability and reasoning. And understanding the distinction is what allows you to architect AI systems intentionally, instead of just following the trends. So where does this leave us? The real advantage isn't choosing between flows and agents. It's actually combining their both strategically. This is what we call the sweet spot. Agentic workflows. You embed intelligent AI steps like summarization or intent detection inside a structured rule-based pipeline. That way you get reasoning where it adds value, while keeping the overall system controlled and predictable. This approach is especially important in regulated or mission-critical environments. You can maintain even oversight, keep actions auditable, and reduce compliance risk, while still benefiting from AI-powered insights. From an implementation perspective, teams often use workflows platforms like NAKN or Make.com to wrap more advanced logic inside clear orchestration layers. It's controlled autonomy, not full independence. Now it's important to acknowledge the trade-offs as well. Fully agentic systems require more infrastructure, more compute, and more specialized expertise. They also introduce governance concerns, accountability bias, and the need for monitoring and fair sales. In practice, we already see balanced model emerging. In fraud detection, workflows catches more patterns, while agentic AI adapts to newer ones. In customer experience, workflows handle routine tasks, while agents manage complex personalized interactions. So the future isn't one or the other. Use workflows when you need reliability and predictability. Use full AI agents when adaptability truly matters. And the most effective systems when strategically combine both.